Lastly, let's just mention very briefly some solutions, because this is necessarily getting into a part that's more political that I want to get into. But I want to mention some of the ideas that are out there, just in a general sense. We can make changes to the energy sources we use. If we don't change the energy sources we use, we can capture and store that carbon that is emitted from fossil fuel burning. We could do geoengineering to do things like make the whole planet more reflective. Or we could just adapt to the changes that are going to happen. Abandon coastal cities and build them further inward. These are all possible solutions that we can make. I will point out that, we could deploy low carbon energy sources. Some of these do have other impacts, right? Nuclear plants certainly have sort of a NIMBY effect where people are worried about nuclear accidents, and possibly justified. It's a little above my pay grade to decide. But if we look at, natural gas versus coal, we see that natural gas emits about 60% of what coal does in terms of CO2 emitted per energy of unit you get out. So switching to natural gas is a net benefit over using coal. But when you compare that with wind and nuclear and solar and hydro electric power, these emit less than 2% of the greenhouse gases that coal would emit. And that's accounting for things like, making the wind turbines and, driving your equipment up there to build all of these. And any emissions that come from breakdown of these materials after they're decommissioned. So changing to those low carbon energy sources would have a big impact on the CO2 emissions. Carbon capture and storage was one thing I mentioned, where if you have, a power plant that's burning coal, there are some ways that you could capture that CO2 from the waste stream, from the stuff that you're normally going to spit into the atmosphere. You could either use that CO2 in products, or you could use it to get more fossil fuels out of the ground by, shoving it underground, or just shove it underground into onshore or offshore storage places. These are technologies that we're trying to develop, but that so far it actually takes more energy to store that CO2 than it does to just, to not do it, than the energy that you got from burning the CO2 and creating the CO2 in the first place. So, if you get, 1 kilojoule of energy from burning your coal in this case, it might take 1.2 kilojoules just to port it to somewhere where you can stick it underground, or put it on a ship and store it in an offshore location. It's technology we're trying to build, because if we can get this number down, then it's viable. But right now it is not a viable solution. It's something that we're hoping we could develop the technology to make it useful so that we can keep burning fossil fuels. If we look at the range of energy costs today, the costs just directly of using these energy sources, this is the range of fossil fuels that this one particular report has suggested. And we find that as we've been developing these, that things like wind power are now roughly in the range of producing energy from fossil fuels. Solar power, some places it's a lot more, some places it's about equal. And over time, it's going to get even closer to in the range of fossil fuel electricity cost, to the point that we can get to where it's not a cost benefit to use fossil fuels. Fossil fuels take a lot of energy to extract those fossil fuels too. So there comes a point where it could be economical just to use these renewable energy sources. What doesn't that include? Well, it doesn't include things that you've probably heard and thought about, which is that you don't get power from wind turbines if there's no wind blowing. You don't get power from solar energy during the nighttime, and you get less during winter months. So those are important things to keep in mind too. We don't have the ability to just replace all of our energy use today with these renewable sources. But the hope is that we can get to a point where we can store this energy somehow during the day, and batteries or in by pumping water uphill. Actually, that's another way that we've thought about doing it. But if we can store that energy somehow, that release it when the energy sources are not producing for us, that we could get away from fossil fuel use. It's also not really possible for us to make fuels directly with a lot of these renewable sources yet. Although things like electric vehicles, a lot of folks are hoping that would be the solution. Also, you might hear about fuel cell cars. Anyway, there are a lot of solutions that we're not going to get to talk about in here, but are worth thinking about. And if we can get them to a point where they're economical, they are worth using. I will just point out that there are two classes of things we can do. Most of what we've talked about so far is mitigation, ways to reduce our effects. Whereas adaptation are things that we will have to do to change how we interact with a changed environment. You know, this is how we react to the changes that happen. So we can mitigate climate change by limiting the amount of CO2 we release. But as you saw, we're going to have some changes regardless. And so we're going to have to adapt, possibly by moving some infrastructure that's along coasts, things like that. So what are some examples of mitigation they have here? Increasing our energy efficiency, switching to renewable energy, electrification of industrial processes, so we're not burning fossil fuels directly there. Adaptation involves building infrastructure to stabilize or move those seaside towns. It involves directly having to restore landscapes that have been damaged in some way by climate change in a way that prevents us from using them in the same way. So those are just some examples there of adaptation versus mitigation. We've also seen geoengineering, things like solar radiation management suggested as a way of of mitigating the effects. Things like, you know, putting a bunch of aerosols directly into the stratosphere to scatter light. But they have so many uncertainties still, so many side effects that are possible, and so many risks. And implementing them would mean that we'd have to be developing that technology along with other considerations. You know, if we're going to spit a bunch of aerosol into the atmosphere, who is that going to hurt? Is that going to affect certain people over others? And so right now, it doesn't seem like, given that and all the unanticipated consequences these things might have, that geoengineering is a silver bullet in any way. It's really not. I'm going to leave you with a couple of sources. If you're interested, you can go look at. Lots of good places for, you know, tracking temperature, for considering the science behind it, for considering what the impacts are going to be. And then, you know, a couple of places that you can look for who I generally consider to be a reasonable scientist who somewhat opposes the consensus. Although I do want to point out the consensus is still on the side of we are causing the current climate changes that are going on today. But I don't want to suggest that nobody thinks any other way. So I give you a bunch of sources here to go check out. Thank you for listening to this lecture. It was a long one, but I hope it's a rewarding one for you. And once again, if you don't agree with things that I've said today, go look at some of these sources and try to consider for yourself ways that you might disagree with them in a more informed way. Thanks, folks.